In this video, I'd like to solve the differential equation x double dot plus 16x is equal to 144 with the two initial conditions x of 0 is equal to 5, x dot of 0 is equal to 12, and I'd like to solve it using a table. Now, the first thing with this table, we need to determine, are we using a first order differential equation or are we working with a second order differential equation? To determine that, we look at the differential equation, we find the highest ordered term, for the differential term, which is an x double dot. So we know that it's a double dot, which is a second order term, and that tells us we're going to be working with a second order differential equation. We also need to make sure that we are loosely in this form that's given right here. And I say loosely because, yes, it's important there's no coefficient in front of the x right here, but this term doesn't exist in our equation, and that's okay. But we do have a x term, so b is not equal to 0. So we're okay there. How do we figure out which row to use? Well, we look at those coefficients, the a and the b coefficients, and we compare them to these tests. Now, this is going to tell us if we have distinct real roots, repeated real roots, imaginary roots, or complex roots. And depending on which we have, we'll deal with how do we find those roots. So how I'm going to do this is I'm going to just work my way down this table like so, even though the title of this YouTube video is going to tell you what the roots are. So let's list out what our variables are. So our coefficient of a is equal to 0. It doesn't exist. Our coefficient of b is equal to 16. Our coefficient of c is equal to 144. B comes before the x term. C comes on the other side of the equal sign. So now we just start testing this. A squared greater than 4b? Well, is 0 squared is 0. Is this greater than 4 times 16, 64? No, it's not. So we know it's not distinct real roots. Okay, is a squared 0 equal to 4 times 16? No, it's not. It would need to be equal to 0. So we know it's not repeated real roots. Okay, the next one is a equal to 0. It is. A is equal to 0. And is b greater than 0? Well, b is greater than 0. B is equal to 16. So we know 16 is greater than 0. So we are going to be working with imaginary roots. Now, this table, it makes finding the roots very simple. So with imaginary roots, we just need to use this entry right here. Our roots are equal to plus or minus omega times j, which is the imaginary number. And omega is equal to the square root of b. So let's do that. Omega is equal to the square root of b, which is equal to the square root of 16, which is equal to 4. So that means my roots are equal to plus or minus 4j. And the j, again, is an imaginary number, which are these imaginary roots. So now we have figured out what our roots are. We can write our general equation for the solution using the table. It's going to be this entry. And the one thing I would say is make sure you plug in the numbers that you know when you're writing this solution. So you want to write in omega and you want to write in the c over b constant. Now let's write this. So x of t is equal to c1 times the sine of 4. We know omega is equal to 4 times t plus c2 times the cosine of 4 times t plus c over b, which is 144 over 16. So c is equal c over b is 144 over 16, and that's equal to 9. So now I have my general equation. What I need to do now is I need to solve for what C1 and C2 are. And to do that, I need to use my initial conditions right here. Oops. This initial condition, x of 0 is equal to 5, means x at time is equal to 0 is equal to 5. And I'm going to write this out more explicitly. And when you get more comfortable with these equations, you probably won't need to write out every step that I'm doing. So what we do is x at time is equal to 0 is equal to c1 times the sine of 4 times 0 plus c2 times the cosine of 4 times 0 plus 9. And this is equal to 5. All right. Let's simplify this a little bit more. C1 times the sine of 0 plus C2 times the cosine of 0 plus 9 is equal to 5. What we see, sine of 0 is 0. Cosine of 0 is 1. So we have C2 plus 9 is equal to 5, and C2 is equal to minus 4. So we're able to solve directly for one of these coefficients that we have. To solve for the other coefficient, we need to use this other initial condition. Now, this initial condition says, all right, this is x dot at time 0. So how do I get x dot? Well, I take this equation that we have right here, and I differentiate this equation. Now, this is where it can get a little tricky sometimes, depending on what the function is. If it's a more complicated function, so if you're dealing really with a repeated real root or a complex root, these functions can get a little complicated because you have these extra terms. You have to do some chain rule things. So that's where you can sort of make some algebra mistakes. But this one's pretty straightforward. So x dot of t, we differentiate this. It's going to be equal to, this is going to be 4c1. The derivative of sine is a cosine. So cosine of 4t. The derivative of a cosine is a minus sine. So a minus 4 times the sine of 4t. And this term, the 9, is a constant, so it's 0. And this is sort of the general form of that derivative. Now let's do what we did with the first equation and input our zeros. So we'll have x dot of 0 is equal to 4 times c1 times the cosine of 4 times 0 minus 4 times the sine of 4 times 0. And this is equal to 12. Okay, so we get, this is 4 times c1 times the cosine of 0 minus 4 times sine of 0 is equal to 12. And again, what do we have? We see that this is equal to 1. This is equal to 0. So we have 4c1 is equal to 12. And c1 is equal to 3. So we found both of our coefficients. Now we just need to write the final solution that we have. So x of t is equal to c1, 3, times the sine of 4t plus c2. So that's a minus 4. Minus 4 times the cosine of 4t plus c over b, which was 9. So plus 9. And this is the final answer, the final form, the particular form of this differential equation. So hopefully now you have an understanding of how you can use this table to go through, figure out which entry to use, figure out what roots the differential equation has, and how to write the general and particular solution of the differential equation.